Hello viewers, welcome to the next section, Finding Relationships Between Variables, Regression Techniques. In this section, we will learn about searching linear relationships and creating a linear regression model. Now we move on to the video, Searching Linear Relationships. In this video, we will determine the coefficient to compare the performance of the two models. To introduce the key concepts, we will get started with a simple linear regression example. From the file vehiclesitaly.xlsx, import data in table format. Find the linear regression relation between the vehicle registrations in a state and the population of a state using the \/ operator. This operator performs a least square regression, which we will see now. Type vehicle data equals read table with the value as vehiclesitaly.xlsx, and then type summary vehicle data. It gives the variables like this. Now, assuming vehicle registration as the response variable y and the population of a state as the explanatory variable x, we can calculate the slope of the regression line simply by typing y and x values. Then set alpha equals x, divide y. As you can see, we got the alpha value. In this case, the intercept is equal to 0. We will now calculate the number of vehicles checked for each state from the state's population using the newly found relation. After that, we will see the regression by plotting the actual values of y and the calculated values. Remember, hold on command retains plots in the current axes, so that new plots added do not delete existing plots. As you might expect, there's a positive association between a state population and the vehicle registrations. Next, we will draw a least square regression line. To do this, just calculate the difference between the observed values and the fitted values. So type residual value, and then type stem residual. The last command shows those values in a chart. For this purpose, we use a stem plot. It plots the data sequence as stems that extend from a baseline along the x-axis, as shown here. The analysis of this image shows that residuals appear randomly scattered around 0 with a good approximation. The better the linear regression fits the data in comparison to the simple average, the closer the value of r squared is to 1. Let's see how to calculate it in MATLAB. Type r square 1 equals 1 minus sum with values assigned to it. Let's improve the fit by including a y-intercept in our model. To do this, insert a column of 1 into x and use the \/ operator another time. So set x with values and then set x divide y value in alpha beta. You can see the alpha beta value here. Then type vehicle registration fit2 equals x multiplied into alpha beta. After that, scatter values as x, y. After scatter values, type hold on. Finally, plot x vehicle registration fit. You can see the output here. Now calculate the determination coefficient again to compare the performance of the two models. Type r square 2 with values. From the comparison of the two values, r square 1 and r square 2, it is evident that the second fit, with a y-intercept, is better. This graph shows two linear regression models, with and without intercept, to compare the performance. We will now move on to the basic fitting interface. We start by importing data. So type vehicle data equals read table with vehicles Italy.xls. Then draw a scatter plot of population versus registrations by using this scatter command, with values as vehicle data.population and vehicle data.registrations. This opens a figure window. At this point, we only have to use the graphical interface offered by the Basic Fitting tool. To open this tool, go to Tools Basic Fitting from the menu at the top of the figure window. In the window that will open, but above all, we choose the type of regression we want to run. We expand the window by clicking on the arrow button in the lower right corner of the interface to show 3 panels. We can select the source data. Now we can use these panels to select a model and plotting options, examine and export model coefficients and norms of residuals, examine and export interpolated and extrapolated values. In our case, we will perform a linear regression again. We have seen the basic fitting window with 3 panels, the choices made, and the numerical results obtained. In addition, in the basic fitting window is the equation of the model with the numerical results of coefficient and norm of the residuals, as you can see here. In this figure, we have seen the scatter plot of the distribution with the straight line results of the regression analysis. In this video, we have learned about searching linear relationships.